Wait for 2-3 minutes more. Am I audible properly?
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes, sir.
Akash, you are there?
Yes, sir.
Whatever the other two, Bhavan
Yes, sir. I also present.
and
Yes.
yeah, Shashank.
Yes, sir. I'm present.
Fine. All right. Shashank has done this course, right?
Yes, sir. I took this course.
And what are you working on in your project?
So my project is also computational based, and I'm studying the quench of a topological superconductor and a normal metal quench.
Okay, okay. With whom you are working?
I'm working under Rajiv with
Rajiv.
Rajiv
Okay.
sir.
Fine.
Yeah,
All right.
Rajiv Singh.
Okay. Is there anybody else who is working with Rajiv and still and is TA? Do you know in your batch? Shashank?
There is one guy, sir, Vedant. He's TA for other course, electromagnetism, the first year course.
Yeah. Okay. But you were also TA for 101, right? I think you were removed now.
No,
But
I
anyway,
wasn't TA, sir.
he
I
was
was
there
TA.
as a reserve, but probably
Okay.
will be removed now. Anyway,
Okay.
all right. Okay, so let us start. So as you can see my screen as well, right? So I have opened the classroom portal in the left, and you have for today what we will do is all there. So this is will be very basic introduction to Python today and the next class as well, next lab class, and we'll not learn a lot of Python here. We'll just learn whatever we need to start scientific computing. And the idea is that as we go along, we will learn the rest of the things which will be required. Okay. So what we should do first is to see that how to do Python. And older days we all have to use we have to install it in our computers. But there is a Google program called Google Collaboratory Laboratory, where we can actually use their interface to run Python. It all runs there. You don't need to install anything. If you are doing a project in which you will be using Python, then I will suggest you to install the Anaconda package. Anaconda has most of the things that we'll need in Python and more. So if you just install it in your computer, then it will work. But for this lab, this Google Colab will suffice, and it will be actually more useful than other ways of doing Python, because it offers you this thing called it's like a Jupyter notebook, which is nothing but a place where you can write your codes, your comments, everything, and you can use a single notebook for your entire course. And we'll see that how to do that. So I have created a Jupyter notebook which will be used by the instructors only today myself. And I will show you around that how to open the Jupyter notebook and how to do things in that. So what I suggest is the first thing that I will show you is how to open a Jupyter notebook, a new Jupyter notebook, which you will do for yourself. So say, for example, I go to Google Drive, and all of you have a Google Drive because it's a part of your email IDs. And when you are in when you are logged in with your institute email ID, you can use this. You will see that this 3x3 grid over here, these are all the apps from Google, and you go to Drive. I have a lot of things in the Drive. So what you can do is you can create here a new folder called, say, Computation Lab. Just go inside the folder just like you go in your normal computer. And now if I click on new, there are so many things that I can create here. This is just like, this is like Word document, this is like Excel sheet, this is like PowerPoint slides. All these things you can create in Google itself. This will all stay online and you can share with somebody very easily. Google Forms is what we use to create your quizzes. But then when you go to more, you will find this thing called Google Collaboratory. Okay, so I request all of you to try this right now because then you will learn how to do this. So what I do is I just click on this and it opens a Python IDE integrated development environment where you can write your code and run it, etc. And what I will also suggest is that, so this can be a single thing. I will show you that how you can compartmentalize things, different days work, but it will be useful for us to grade you also because we can just look at this and know that how much work you have done. So here, you can give it a name, and I'll suggest you give it a name which is according to your roll number, like say somebody. So what, Akash, what is your roll number?
20171506.
Okay. So you create this according to your roll number. So then this is your file that I know. And later your tutors will show you that how to share it with the tutors. So whoever is your tutor, so we have 3 tutors now. So one of them will take care of each student. I mean that you will be broken up into 3 groups later, and then each tutor will take care of one group. And you can share it with your tutor. The tutor can see whatever you have done. So this is how you create your, you can call it as a laboratory notebook, but it's a very special notebook where you can even write a Python code. Okay, so can you all first try this and create your own laboratory notebook in your own Google Drive? If you have any problem, please contact any of us, and I mean, today I will tell you.
Sir, would you show how to make this again in Drive? Like you went to the folder and you created it?
So yeah, I created a folder that is just to keep things organized, right? And then I go to new.
Yes, sir.
And I go to more, and here is your Google Collaboratory.
Okay, sir.
So can I use the Anaconda?
You can use. So okay. So anybody, if you want to use anything else, you are all welcome to use whatever you want. The only thing is that maybe that we will not be able to tell you all the time that what goes wrong in your particular IDE. Okay. So that's why we want, I mean, to use this. But if you are confident to use any other developer environment, you can use. There is no harm in that. This is the easiest one, I think.
Hello, sir.
Yeah, go ahead.
Sir, I couldn't find this option Google Collaboratory in my Google Drive. Do we need to install something for it?
Right. So you may have to connect more apps in case you don't have it. And then you will see that there are a lot of options for new applications. And there you will find it.
So we have to make a Google Collab sheet just like you did, but with our roll number
Right, right,
CL21117008.
right.
Okay, sir, I
And
did.
that is easier for us to keep track of things, right?
So, sir, you can view these files, the one I created.
Not right now. So that part we will do later. Right now, you don't need to do anything. So that part
Okay,
we will
sir.
do later, one by one, step by step. Okay. Who was asking? So in case you have not found, you just search here Google Colab. My case, it is already installed. I mean, it's already included in the package list. Anybody else have problem in this?
Sir, I have a doubt.
Yeah.
Although I have renamed the that Google collab
It
file
will take
to.
some time to. It will take some time to get it changed here.
Okay, okay, sir.
You can, if you refresh the drive, then it will get it changed. Anybody else have a problem? I will give you 2 more minutes, and then we will proceed.
Sir, can you please repeat that step where you gave the name to the file?
Oh, it's just, so you have opened the collab, right?
Yes, sir. I opened that.
So here is the name of the file. You can just edit it.
Okay, sir.
In case it's not in this list, you have to say connect more apps, and then you have to search for Google Colab and install it. Install means it will be added to your apps. Search here and add to your apps.
The extension is called Collaboratory.
Yeah. Collab is short form. Yeah, Collaboratory.
Sir,
Yeah.
sir, if we're doing all the work through Anaconda, we won't face any problem in submitting the files if it is required to.
So you have to then contact your TA and convince him that he will submit it on time every time to him.
Sir, so we can do it in Anaconda, right?
As I said, that you have to contact your TA. The usual practice will be that you will look at the TAs will look at the notebook, the Colab notebook for every student. If you want to do it differently, you have to contact your TA and
So then
convince him
it will
that
be
he will
better
submit.
if we do it through this Google Drive.
Huh? Yeah.
Then will it be better if we do it through this Google Colab?
It will be easier for you, yes.
Okay, sir.
If you are comfortable in writing the code in Anaconda, after you write, you can just copy paste it here. That also will work for you, right? Okay. All right. I guess, is there anybody who has problem? Please tell now. Otherwise, I will proceed.
So actually in my computer Google Drive is not opening.
What is it showing?
So it doesn't show anything, but it's not opening.
No. So have you logged into Google with your institute email ID?
Sir, can you repeat the process once again?
Okay, all right. So Ankita, what we will do is we'll do that just after, because right now you don't need to do anything. So when it will be your turn to do things, so then one of the tutors will help you. Okay. So right now I will be showing things only,
Okay.
because otherwise the rest of the class will wait, right? Okay. So right now I will be just showing you the basic things in the Python. When I ask you to do something, then one of the tutors may help you. Fine. Okay. Okay. So anybody else has problems? So we'll have I will ask you to do a few things today. So then at that time, one of the tutor will help you. Fine. So what do I have here? So I have, to start with, you can see that the new collab I have opened. So it says 1, so which is the line number. You can have a few settings here. You can say what font size you want. Do you want the line number or not, etc., etc. Don't bother about all these things to start with. These you can say it later. Okay. Here I can write whatever I want to write. Now, this is the collab that I will be using, and you see that I have already written a few things here. So first thing that I will write, and if you are maintaining a single collab notebook over all your entire computational physics course, you will start with computational physics, whichever the lab number and the date. So then you will know that part is from that. And whatever you are doing, you can write your own notes here, which will be helpful for you as well, that you will remember what you have done. Most of the time, when we write a code, if the code is not written very well, then after a few days, we look back at the code. The code is in a language, just like the language we are using now is English. So the code is in a particular language, which is in this case Python, and then we may not understand what the code actually is doing. Even if I have written the code. So it's better to keep comments. Like I have written a few things. Here we can write Python program or scripts. Then we use the arrow at the left to execute it. So if I write a code here, I can use this arrow to execute. Alternatively, if you execute it and see what it gives, that is the results. Alternative to the arrow at the left, you can also use Shift plus Enter. So that also executes the code. All right. Now, when I am writing all these things, you will see that suddenly and has a different color. See, the and is highlighted differently. It's highlighted. It's with certain color. This is because there are parts, these and is, these things are part of Python language syntax. So those are used in the language to do something. So like, for example, A and the. So these things, the articles are part of English language. So if you call somebody with a name the, so then it will be a problem. So these things, so that's why these are highlighted separately. So what we need to do is to tell Python that this part is not a part of the code. This part is a part of my comment. Okay. So how do I tell that to Python? So what I do is, if there is a single line which I want to comment, which I want as a comment, I put a hash before that. You see the color changes. That is because the Python now knows that it's a comment. So I put 2 hashes such that this also is of course not a part of the code. So these becomes, Python knows now that these are comments. But when there is a block of text, a lot of things I have written here, this is not very easy to put comments in front of all the lines. So Python has an alternative. We use 3 dots at the beginning of this block and the end of this block. And what it does is make this also as a comment. So if I, as I said, that if I click on this, it will get executed. So if I click on this, let's see what happens. It is taking some time because it's connecting to the place, the computer where it is running, and it's telling you that this much RAM and this much disk space is written, is available. So it just gives you this output, which is nothing but the comment that you have written. So there is no computation that is asked. You see this slash ends over there. So we'll know shortly that what does it mean. But anyway, so that is the output. We don't need that right now. We have not done any computation, but this is how you write a comment, which is very useful for you. So you should always write what is the question that you are trying to answer, what is the problem which is given. You can keep it here under a comment, so you will know that which problem you have solved. And then we will learn, before you just write the code, we need to write something called a pseudo code, which is how the code what the code will do step by step, but not in the language of Python, but in our language. So we say that first we will read, then we'll read another variable, and then we will add to these 2 variables, and then we'll print the result. So like that. So we'll see what it is. Okay. Now the
Sir,
yeah.
so you can comment big blocks of text using select all the text and just click Ctrl+/. That would do the commenting.
No, see, there are many other ways to do it, but what I will teach you are the simplest ways. All right.
Okay, sir.
There's no point in teaching many things to a class of students and confused everybody, right? All right. So now, say I want to do some numerical operations. Like, for example, I want to add, subtract, multiply, divide, etc., etc. So those are the first things that we will see how to do. And let's add 5 with 3. Now I use Shift Enter, it's easier. The result is 8, which I think that is not very surprising. 5 minus 3 is 2. 5 times 3 is 15. 5 divided by 3. Now, what is 5 divided by 3? What do you expect as the answer? Let's say 5 divided by 2. What do you expect as the answer?
2.5.
2.5.
2
or 2.5?
2.
So 2.
Why 2?
So because both the numbers are in 1-digit format.
Integer.
Right. So see, if you already have a C background, so then you will start to think that when I write 5, it's in integer form. So Python doesn't use a default type casting, which means that there is this 5 can be treated as a floating point as well. So when you run, you will get 2.5. Okay. So Python understands that these are 5 divided by 2 is not 2 and remainder 1, but it is it's actually 2.5. So it will give you 2.5. So there, you see, before using 5 and 2, I never said that whether they are what type of variables they are, which will come to shortly. But Python, if you don't tell, then it does not bother. If I want to get 2, then I have to do this. Okay, so I have to use the slash. Slash is the division sign. Star is the multiplication sign. So I have to use slash twice to get 2. Okay, so let me keep that here, or I'll keep a few things here because which are not trivial, such that you can have a look at them later. Okay. See, what I have done here is that I have gone from this block to the another block, because this block executes and the final result is shown here. Okay. So if I have another, so if I have 5 plus 3 here, come to the end of the block and execute, I'll still get 15. Okay. So now we know that how to do an integer division. This is like 5 and 2 are treated as integer. But what if I want to know what is the remainder? So the remainder, to know the remainder, I can do this. Sorry. So that's the remainder operator that gives you the remainder. Okay. And if I want to do 5 to the power 4, then this is this. Now, if I really want to teach you, what I should do is, I should write down comments. Like when you are also learning first time, you can keep your comments like this, and then you can look at it if it is required at any time. Sorry. And all right. Any questions so far? So these are very basic things. But if you have any question.
Sir, we can also use 5 to the power of 4 as power of 5 comma 4, right?
You can use. So if you say that, so let's check if we can use that. So 5 power 5 comma 4.
Yes, sir.
Okay. So see, whatever you want to check, you can just check it here, and then it will say that it will either give a result or give an error, right? So there is another way in some syntaxes. It is used this way with a cap sign. Let's see what happens now. So this gives you 1.
That's
so
an OR function, right? That's an OR function. That's a logical OR.
So that's a logical OR function. Okay. So the logical functions we are not going to right now. So let's see now. So far, what we have been doing is that we are using just the numbers, right? So 5. This okay. So let me emphasize this fact. So this is not how you can do 5 to the power 4 here. It does something else, which is logical OR. Sorry. Fine. So these are 2 ways of doing. Say I will prefer this because it requires less characters to type.
Sir, in line 16, you have written 5 plus 3, but it is not displaying the output of the same.
It is not because, so I have not broken it here, right?
Yes, sir.
So that's why it is not giving you the output. So it is giving the output after the last line.
Okay, sir.
Sir, in Python, don't we add any type of header files?
We'll come to that. Wait. See, whatever you have done, so let us. So this is straightforward, right? So let us now come to. If now, see, most of the times in Python, you will see that if you want to do something, somebody has written a code for you. You have to be clever enough to use it. Okay. The same thing we also do for any other languages. In C, they are called header files. In Python, in C, they are called header files, and what you import through those header files are called libraries. Okay. So in Python, all that is already there written for you are in Python modules. Okay. So these are called, in Python, these are called modules. A very useful module for numerical computation, which you will do, right? So there Python can do. Is anybody else logged in here? No, right? Okay. For numerical computation is called NumPy. So NumPy, you can say that it's numerical Python. Okay. This is something we will always use. Okay, so always in every code we will use NumPy. So let me keep this in comment. Now the question is that how do I import such a module? So importing NumPy. Now there are many ways, and there is one specific thing that we will follow. So I will do it this way. Import NumPy as NP. Okay. Here, NP is a nickname for NumPy. So I don't want to use 5 characters to call NumPy. I want to use only 2 characters to call NumPy. So that's why I have imported it as NP. Okay. So now this is like if you have done C, this is like a library. So NumPy is a module. It's called a module in Python. It's actually a library. So it has a lot of functions, class, etc., defined in it. Now, so what do I mean by that? So let's say that I want to calculate sine of 30 degrees. Okay, or sine of say 0.1. So I want to calculate this. And you try to calculate and it says that sine is not defined. So sine function is not defined in Python by default. Okay. So what I do is that I take help from the NumPy library. Somebody has written that function in the NumPy library. So when you do import NumPy as NP, so all those functions will be available to you. So I do import NumPy as NP. I do a shift enter such that NumPy is actually imported. And now if I want to calculate here sine of 1 or sine of say 0.1, still I will not get anything. So what I need to do is I need to tell Python that use the sine function from NumPy. So that's how you do this. np.sine means that use the sine function defined in NumPy. You may not know how to write the argument of the function. So what do I mean by argument of the function? So you know that when I write a function, so let's say that how to use a NumPy function. I'm sorry, I'm hitting shift enter all the time. How to use a NumPy function. Okay, so let's ask this question. So a normal function we write as a normal function of one variable how do you write? So fy equals to fx. right? So you write within a single bracket, and because it's a function of a single variable, so you have only one thing there. So you'll learn about function in a later class, but the same way you write a function in Visual, it is same in for Python or most of the other languages, is that you write that .1 within a bracket after np.sign. np.sign means it's a sign function from NumPy. So now if I run this, it will give me output. It will give me a number. Now, if can anybody please count the number of places after the decimal and tell me how many number of places are there?
Yes, sir.
Okay, so then count and tell me.
17.
17.
Yes, sir, 17.
Good. So we'll learn in the maybe next to next class why there are 17 digits. Okay. So if you have done C already, so then you should know why there are 17 digits here after the decimal. Otherwise, we'll learn this after the next week mostly. So this is sign. Now, similarly, the functions, the name of the functions are not very difficult to guess. So I can do all this all the time. If I do exponential np.exp, okay, etc., etc. Now, say I do not know what, there is a function called log, and I do not know what it does. So it also gives you all these. So when you write it, it also gives you all the options which are available. But if I want to know what the log function does, say it's log, you know what it does, but maybe something you do not know. What you can do is you can put a question mark here, which is asking the Python that what it does. So it is giving you what it does, just like a help. Okay, so there are little bit complicated things, but you can see that log of exponential x equals to x. So you know that it is the normal log function. And then at the end, it also gives you some examples, np.log. It has, so what it is we learned, but so it has calculated the log of each of these and given you the output. Similarly, you can, so there is a function log10. So if I put the question mark, it will. Now, if it doesn't give, so you can, if you enter, so then there is more detailed help that will come up here. Okay, sometimes it may not load, the help may not load directly in your browser. So if you put shift enter, so it will give you the entire help page over here, and then so that you can read everything here and understand. Okay, so these are about the functions. Any question?
So, NumPy is inbuilt module or you built it?
See, okay. See, the other advantage of using Collaboratory is that all the modules are already there. So you are running this in one of their machines where all these things are inbuilt. So NumPy is it's not in the bare Python, obviously. It's an extra module, but there are few extra modules which as scientific computation, in scientific computation you always use. So NumPy is something that you'll always use in all scientific computation. You write a code, this import NumPy as NP will be there, definitely. Okay, so if you want to install these separately, you have to install it separately in your computer.
So in any extension like Visual Studio Code have also this inbuilt module NumPy?
Which one?
Visual Studio Code.
No, see, Visual Studio is not a code. Visual Studio is a integrated development environment, IDE. So Visual Studio is like this Colab that you have opened here. So it let you write programs in a very visual way, if you wish. Okay, so the NumPy does numerical. NumPy is a class of numerical computations only, and most of the things one does are already written in Python. I mean, somebody or else has written a module, or there are many different modules available for a given task. So it has become a very useful language nowadays. There are pitfalls also. It's not that it's all good. I mean, obviously, if you want to run a very sophisticated program which takes a lot of time to execute, etc., you should write it in C, Fortran type of language for numerical computation. But yeah, so that's for very sophisticated programming. Okay, so let's proceed. Now, once we are in NumPy, so NumPy also what it does is it runs, yeah, modules and libraries are same. So what we call module, let me keep it here, we call set here, right? Modules are like libraries in C. Okay. So let's see. Now, as I said that when you are doing the division operation, we realize that Python do not distinguish natively between an integer and a float. But NumPy does, because see, NumPy is written, if you ask the question that how Python is executing all these operations, what NumPy does is that when you write a code, it kind of quote unquote transfers it to a C code and execute that C code. Okay, you may think that why then I will not write it directly in C. The simple answer is that for a piece of code which requires 5 lines to be written in Python, you may require 50 lines in C. Okay, may run a little bit slower, but it doesn't matter with the fastest computers that we have today. So because it executes the program in C, it needs to distinguish between integers and floating points. Okay, so now I guess that some of you are not aware of floating points or integers. So these are called data types. So let's discuss a little bit about the data types. So now these will be we'll discuss these in detail in the class and how are they implemented in a computer. So we'll discuss these 3 data types. There is another one which somebody was pointing out. It's called a Boolean data type, which is true or false. But you can have a look at it by yourself. So what is an integer data type? Integer data type is something we know that you know as an integer. So integer is an integer. Okay. So floating point is a fraction. So floating point is used to represent a fraction. Integer is used to represent an integer. And string is used to represent piece of text. Okay, like let us now take some examples of this. If I can define variables, and then let's see, a variable can have one of the data types. So if I have a variable, say a, say write a equals to 1. Okay. So at this stage, Python, even NumPy doesn't need to know whether a is a integer or a floating point. Okay. But say I want a to be a So what does a equals to 1 mean? So let's first address that question. It means that I have a variable, just like the variables we have in normal computation. The variable is set to 1, and as you can see that it has understood that it is an integer because I do not have put a floating point, a point after a. Okay. If I put a point after 1, then it will be understood as a floating point number or a fraction. Means that now I can do 1 divided by 2 will give me 0.5. So a is a variable which I have assigned a value 1. So this equals to is an assignment, is called an assignment operator. Similarly, I can have a variable b which I give a value say 2, and I have a variable c which I give a piece of text as the variable value. So c can also be a variable which is called Proshun. Now the computer remembers that a is assigned a value 1, b is assigned a value 2, c is assigned the string Proshun, which means that these numbers are saved in memory locations. The memory locations are labeled as a, b, and c for us. Okay. So if I later try to recall what is the value of a, the computer will tell you that the value of a is 1, the value of b is 2. You see that 1 has come with 0.0, which is it's a floating point, and the value of c is my name. Okay. So any question here? So one example should be good for you. Any question here? It's all right, right? But so one of you were asking the question that what happens if I just write this and then hit Shift Enter, then it only prints C. It does not print A and B, right? Or the result that it shows is the execution of the last line. But what if I want to print all A, B, and C all together? Now see, when I am trying to print C here, or trying to recall the value of C here, what I am doing is that after C, I am running the code, right? But when you write a very complicated long code, which we'll start to do today, by the way, you don't want to print, or you don't want to run the code at each line. So that kind of defeats the purpose of writing a program, right? A program is supposed to execute a set of operations just by itself without you looking at it. So I'll be able to start the program, go to the market, drink a cup of tea there, and then come back and see what is the result. I should not be doing things in between. So for that, what I need are inputs and outputs, which the program can take inputs either from myself if it is required at some point, like when you try to overwrite a file, your computer asks you that this file already exists, do you want to overwrite? Right? So that type of question, that type of input it may take. And if there is a message it has to give you, or has to print a set of strings or set of numbers as an output, it should be able to print an output, and it should be able to print at any line in the program, right? And then there can be a little more complicated things which we'll come to shortly. But the question is that how do I say I want to write a program now? So we want to write a program, our first program. So what is our first program? So let me define the program. Take two numbers as in input and calculate the addition, print the addition. Okay. Let's try to see that how do I write this program. So I need two numbers as input. Now, if you want to write a very sophisticated program which is which tells you everything what you need to do, then first you need a set of instructions coming from the computer to you. So the computer should ask you to input the first number. So for that we use the print function. Okay. And again, as I said, every function comes like the name of the function, and after that there is a bracket. And this function is inbuilt to the Python. I don't need NumPy for this function, so I don't do np.print. Okay. So what is the instruction that you want? Now the instruction is a string, and as you may have already noticed, when I write a string, I write it within this bracket. The quotes. Now in Python you can write it this way, or you can write it this way as well. Whose name you want? Okay, so you can write either way, it will work in Python. So if I print D here, it will print Vishwanath. It doesn't matter whether you use single quote or double quote. What you cannot use is that you cannot start with a single quote and end with a double quote, or vice versa. You have to be consistent. So what I want to print here, this is a message that will come to me as I run the code. So this is input the first number. Okay. And so let's see that how the code will work. So what we need to do. Now that is what we call the algorithm for the code, and this is a very simple one, but still let's start with simple things only. And we write those, we call the pseudo code. Pseudo code means that I will write it in my language and then it will transfer it to the computer language, the Python language. The first is input first number, input second number, assigned to a variable, assigned to a variable, add the two variables, and save in a third for print the output. So these are the steps that I have to do this job, right? And I have done the first step, or half of the first step. So I have asked myself, the program will ask the executor to input the first number, and then now I have to get the input from the whoever is writing the input and store it in a variable. So that is done this way. So after I execute input the first number, so let's see, I can even run the code up to this and see what happens. So it says that input the first number. So I say 3, I say 4, and hit enter. So it has taken the number 4, and you can check if I now ask what is the value of A, the value of A is assigned to 4. Okay. But then you realize that the 4 that it has printed has these quotes in either side. When we were printing A and B, they did not have a quote because those are identified as integer or floating point numbers. What came with a quote is a string, which means now this A has become a string. So it's a string called 4. It's not the number 4. Okay. So if I want to add something to it, it will not work. So what I have to do is I have to convert this string 4 to a number 4, and that is done very simply, but by saying that I want this input to be a number. and I say I want to do a floating point number, I can have something in as input which is 2.3. So I use float. So let's see what happens now. So it asks for an input. So I say 1.2. I hit enter. And now if I say what is A, it gives me 1.2 without any code. The first line is done. And you see that you can just copy these two lines, paste it again, change first to second, change A to B, 1 and 2 is done. Now add the two variables, so AA plus BB, and save it in a third, which I do that I assign the value in the memory location C as the addition of the values at memory location A and B. Okay. And then I finally want to print the output. I can just simply do this. This will print the value in C. I can also, you see that now we are doing a little bit complicated operations, but let's do it and see what happens. I can also do it this way. The addition of percentage %f and percentage %f is percentage %f. Let me write it down and then explain to you what it means. So I use percentage %f because this place will be replaced by a floating point number, so that f is for that. If I wanted to use an integer, percentage %f is for float, percentage %d is for, sorry, and percentage %s for string. Okay. So what it will do is it will replace first percentage %f with A, second one with B, and third one with C. And then it will print. Any question on this small piece of code that we have just written?
So why the double A's?
So I'll come to that. So that's that is interesting thing. But anything else?
Hello, sir.
Yeah.
Sir, if we don't include this line that the addition of percentage %f and percentage %f is this, so then can't we get the addition for it?
Right. But you want to have an output of your program, right? The program has to tell you that what is the output. Right? So I can do this also. I can just print CC. That is fine.
Yes, sir, that's what I'm asking, as we have already converted it using that float command, so we can print
No,
it
that is all
directly.
right. So you can just no. So you can just write this, but you see that you are writing a little bit good looking program, right? Which will tell you what all that is the program doing. Always try to write a program that way, because if you look at your program, I can guarantee you, if you look at your program after 6 months, you will have absolutely no idea what you have written. Okay. So if this line is there, then I know at the end what is that is being put as output. That's all. It's just, if you wish, a little bit of beautification of the program. Nothing more. Any other question? Let's execute. Tell me a number, somebody.
54.
4.3.
69.
Okay, so I got so many numbers. So 69.3. Input the second number.
420, sir.
4.3. 3 is very favorite for everybody. See, okay. So there are few things to note here. One is that when you print C, it just printed 73.6, but when I print it is with percentage F, it has printed 6 numbers after decimal. Just keep this in mind. This will be plain to you why it has printed 6 numbers after decimal when we will in the next set of in the lectures in the next week. Okay. Now somebody asked that why I used 2 characters for defining the variables, right? This is just a good programming practice. Okay, this will help you. This will help you if when you are writing a very big program. So always try to give at least 2 characters to the name of a variable. What happens is that many times you will see that you want to search for where the variable b appeared in your program. Okay, and or say where the variable, say you have a time variable which called t, it appeared in your program. So what will you do? You will do a search on t, right? So let's do a search on t. So I do a search on t, and it says that there are 61 matches because it matches this t and this t and that t and that t and that t and everything, right? And none of them are variable here. We used the variable a. So if I search for the variable a, then you see that how many times it matches. But if I use 2 letters as my variable names, it only picks up the places where actually the variable is used. It's just a good programming practice. There's nothing in the language that bars you to use a single letter, a single character. Okay, so can we proceed? So all of you, now what I will request you to try, or let me, what is the time? So we are now 1 hour, it's all right. So all of you, I will now request you to try to define 2 values of 2 variables and try all the operations that we did earlier. So like I will do it here. Okay, so all right. So let me do it this time. Let me do it myself. So I can do this, right? So once I have assigned a variable, I can add the 2 variables. I have not assigned a variable called c, right? I have not given, so c I have given in the earlier case. I have not given any number to the variable d. So I cannot do this addition. It gives me the fact that d is not defined. So remember in the first lecture we discussed that always in the computation case, you start with the numbers and then evolve them. So this is being apparent here that because I have not given a number to d, I cannot do a plus d. Okay, though a and d are variables, they are variables, but they are essentially locations in the computer memory. And you have not defined any memory location called d. Because of that, you cannot add the value in the number stored in the memory location A with the number stored in the memory location D. Okay, so it's not there. So you have to, if I define it here, then if I run this, then it will work. There is no problem now because that is stored in some memory location in that computer. So I can add these 2 numbers. And you can try all the operations that we did earlier just with numbers with variables now. So I can do, say, a to the power 4, for example. Okay. Now, so any questions so far? Otherwise, we'll proceed to another important concept or set of concepts which we'll be using a lot.
Sir.
Yeah.
Sir, we define AA 2 times. Did it make difference if we command any other thing?
Right. So, okay, good question. So the question is that we defined the value of, we assigned a number to the variable A or the memory location A, right? Which is done here essentially. And then we did it here again. What will happen? Well, what happens is that if you think of these variables as memory location, then you know what has happened. What has happened is that there was some other value 69.3 in that memory location. Now that value is changed to 2.3. 69.3 does not exist in that memory location anymore. It's erased out. So it's replaced by the value 2.3. Okay. You can do very interesting thing. You can do AA equals AA plus 1. So let's see what is the value of AA now. It's 2.1, I guess. 2.3. So if I do AA equals AA plus 1 or say 1.5, it adds 2.3 to 1.5, and obviously I need to print A to see what is the value. So this is 5.3. Okay. So why it is 5.3? It was, see, it was 2.3 here. I just added 1.5. Why it is 5.3? 2.3 and 1.5 is 3.8, right? Any idea?
You ran that cell twice.
I ran this twice, right? So first I was running just A equals to A plus 1.5. A got replaced by whatever it is, then 3.8. And then when I ran with the print command again, so then it got changed to 5.3 because 1.5 is added again. You can see it in action now. So it will be 6.8 and etc. Okay, so every time you do this, it's getting replaced. Value in the memory location A is getting okay. So next we'll discuss a set of things. Yeah.
Sir, if we write AA rather than just print bracket AA, does it make any difference?
It will also print, but again, as I said, that if you are just executing this part in, this is a kind of command line, then it is fine. But if you are writing a big code which will run and then forget, it will execute by itself, then it is not fine. Understood? See, as it is like here, so only D will be printed, right?
Yes.
So that's why. So it's better to use print. When I'm writing a program, sometimes I may need to check what has happened to this variable. What I wanted to do, has it done that correctly? So then I can just print and then check. But then when the program is program is written, debugged, and it's ready, then all the things that the program should print should be within the print command. Okay. So let's define a concept which is called container. What is a container? A container is like, these are variables, right? A, B, C are variables. But sometimes to describe things, we need more than one variable. Like, for example, if I have a particle and I want to study its motion, I need, in 3 dimension, I need 3 position variables or 3 velocities, right? If I have n particles, then I need 6 n such coordinates. So question is that, so when I have so many large number of things, then so each of these things, each of these 6 n coordinates is a floating point number, right? So I have to deal them together. It's not that I will deal them separately. So then maybe I would like to define a single variable which has all these, say, 3n or 6n coordinates, or all the x positions of position of all the particles in a single variable called x, y positions in a single variable called y, etc. Okay, so how do I do that? Now, so in Python allows you to do this in many ways. I will only talk about 3. Okay, 3 ways. So one is called tuple. Before I go into there, so these can be of different types. So let me call these types. So one is depending on whether they are ordered or not. Means I can call the nth variable or nth number in the container. When I give an example, it will be clear to you what I mean. So I have, say, 5 particles, and there are 5 positions defined. So x1, x2, x3, x4, x5. So these are numbered and these are ordered. So I cannot change x2 to x5 and x5 to x2, right? So whatever is in the second position is the x coordinate of the second particle. So then it's an ordered set of numbers. Then you can ask the question that, are they homogeneous? Homogeneous means that is it that all these 5, in case of the positions, all the x values x1 to x5, are they all floating point numbers? In this case, yes, they are floating point numbers. But I can come up with examples where they are not all of the same type of things. Like, we'll see an example at the shortly, which we'll have to do, which I will do and show you how we walk out through the problem. Like, for example, I have to grade your performance in a given course. Okay. So if I want to grade your performance in a given course, what I have done is I have done a tabulation. The tabulation has your roll numbers, your names, your mid-semester marks, your end-semester marks, etc. So when I read these in a, so these are like the similar type of things. But if all the roll numbers are of similar type of things, so they are all integers. All your names are like strings. Your mid-semester and end-semester marks can be floating point numbers, right? Mostly they will not be negative numbers, but positive floating point numbers. But if I ask the question that what is the details of a single student, so in that case, the first thing is the roll number. The second thing is a string, which is which is your name, and then the mid-semester and end-semester marks are floating point numbers, right? So they are different types of they're of different data types. So one is integer, one is string, and 2 are floating point numbers. So whether I have in my container, you see, container is that student is the container, and then he has different things in it in the container. One is his roll number, one is name, one is mid-semester marks, and semester marks. So if all these are of different types of data types, then you call it a heterogeneous data type. If all these are same, then you call it a homogeneous data types. If all the elements have same data types. then in some cases you want to change the values. Like say if it is the first example that we are talking about, where we have all the x position of the particles, 10 particles in one container. In the next time step, as we saw in the last lecture, the position of the particle will change to something else, right? So all the values you have to update, just like we are updating here. Something like that will happen. But in the case of the grading, after I look at your grade and I don't like somebody, so then I should not be changing your end semester marks from 50 out of 50 to 5 out of 50, right? So there are containers where the elements, individual elements, the values can be changed, and some cases the values cannot be changed. Now change is, you know that biology there is a term called mutation, which also means change. So you ask the question if the values, if the elements can be changed. If it can be changed, then it's a mutable one. If it cannot be changed, then it's a non-mutable, or what is it called? Unmutable container. Non-mutable container. Okay. So is this three different things make sense to you? Any question here? Yeah, MSc students. This is a question for the MSc students because you may or may not have programming yet in your earlier courses. The IDT students had a programming class earlier, which was in a different language, but that's all right. Now, my question is that if it is, or my suggestion is that if I'm going too fast for you, please slow me down. Okay. And any problem that you have at any stage, please ask. What is Tuple? Hitesh asks. So we have not discussed it yet. That's the next thing that we'll discuss. It's a type of a container. Is this three properties clear to you?
Yes, sir.
Okay, so there is a container which we'll not discuss called set. You know what is the definition of a set in mathematics, right? So it's some element is either a part of the set or some element is not a part of the set, right? But you don't say that what is the fifth element of a set. Because all the elements, I mean, there is no rank of the elements. This is the first element, this is the second element, etc. So that is not an ordered container. It's a non-ordered container. But that is not something that we will need explicitly here, so I will not discuss it. And there are other non-ordered containers as well. Okay, so let's see what is a tuple.
Sir, why we use containers?
Why we use container? So like I gave you the example, say I have n particles. Okay, n is very large, 10,000. And you want to see the motion of these 10,000 particles. Now your computer is good enough to do that. Maybe your computer is good enough to do that. But then each of these particle has variables x, y, and z, right? Positions, 3 position variables. Think of you writing. Last time we wrote for one particle, one dimension, we wrote how to update, right? So for simple pendulum to the next time step. So I have to write those 2 lines. Imagine that for 10,000 particles, you have to write 10,000 into 3. So 30,000 pair of lines to update the position and velocity of each of those particles. Will you like to do that?
No, sir.
No, right? So what you do is, because they gets updated in the similar way, so you can use a container to save all the x coordinates, all the y coordinates, all the z coordinates, and use that in a clever way too. So that we'll learn how to do that, but use that in a clever way to write only 2 lines of code as we have written, but now for n particles, or 6 lines of code maybe for x, y, and z.
Okay, sir.
Okay. So let's see any other question. Okay, so let's see. The first thing that we'll discuss is a tuple, and what are the properties of this. So this is ordered. In fact, all the containers that we will use are ordered. Okay, so this is heterogeneous. My spelling can be all over the place, but heterogeneous means that different elements of this container can be different. Like we were discussing different data types or even completely different things. And so it's ordered. All the containers, as I said, we'll discuss are ordered. It's heterogeneous and it's non-mutable. So once you have defined the values, you cannot change. Example. We'll keep the example within the comments here. So if I define a tuple called, it's not required that you define tuple A like this, but you define always, I mean, you can call it any variable. So a tuple A, I will define with first brackets. That's why I have kept, or first brackets or parentheses, whatever you call it. So I have kept this here. And inside that, I can define numbers. What I have done, so I have given maybe 3 integers. This is a tuple within a tuple. This is 5 and 4 with these brackets is also a tuple. And then I have a string, and then I have a floating point number. So you see immediately that it's heterogeneous, and the rest of the things that we'll see. So let's take the example. So say let me define this, the variable called AT. Now, question is that how do I know, how do I get these different members of the container? Okay, so there are how many members in this container?
6.
6 members, right? 1, 2, 3, then a tuple, and then a string, and then an integer. Now, so let us write it here. Indexing. The container, the indexing starts with 0. Okay, this is important. This is C-type indexing. What do I mean by indexing? So this one is the 0th, is at the 0th place of the container AT. Okay, so to know what is the value there, so I have to use AT, and then within the square bracket 0, that will print the value at the 0th position of the container. So this, the first position, the first number is at the 0th position. So that is what I mean by indexing starts with 0. It doesn't start with 1. So what is the, so you said that there are 6 such numbers, right? Or 6 such members in the container. What is the index of this?
5.
Fifth.
It's fifth. Right, so let's print fourth, etc. Okay. Now, so this tells me that it's an ordered container, right? That's why I can say that 4. So every time it will print the fourth index thing. We can do a little bit more fun here. So A3 is 5 and 4, right? So that's this element, but that itself is a container, which is, it's a tuple. So if I do 0 here, then it will print 5. So what it is doing is taking the third element of the tuple AT, which is this one. Now that itself is a tuple, and it's taking the first element of that tuple by the second 0. Sorry. So this is 3 and 0. So that's why it's giving me 5. So you understand it's ordered. We understand it's heterogeneous. Let's try to see if it is mutable or not. So let's say I try to change. So this is the first element in the container, or this is the memory location of the first element in the container. The value in that memory location is 1. So let's say that, okay, I will assign this value to something else. I will assign this value to 2. I'll change this. Let's say what happens. So it says that tuple object does not support item assignment, which essentially means that you cannot change this value. Okay. So I cannot change this value. That's why it is non-mutable. Any question? So that's a tuple.
So is there command for searching any numbers in tuple?
I didn't get.
Yeah, which position, which index position is which number? Like if we want to position of 4, then it would print A3 of 2. Sorry, 1.
So what do you want?
So
A4.
I want to know index of value 4.
Okay, so that can be done. So we'll do that. We'll do that. So we'll do it a little. Wait for a little while. We'll find that. How to do that. Okay. So let's go to a different container type. It's called a list. And let me just write it. It's also ordered, heterogeneous, but it is now mutable. So somebody has asked that why you use a square bracket 3 here. The reason is very simple. See, this bracket is mostly conserved for the functions. Okay. So if I try to write AT and then something like this, Python will try to interpret AT as the name of a function and then try to seek for what are the inputs to that function. So it cannot, I mean, obviously AT is not a function. So that's why you use for all the ordered tuples, sorry, all the ordered containers, to get the nth value, you use this. Raman, does that answer your question?
Yes, sir. Understood.
Okay, so this is ordered, heterogeneous, and mutable. Okay, for example, so let's say I call a list. You can search in internet or anywhere that what is the main meaning of a list, how it is created, etc. If you are enthusiastic, I will not go through those things because that is not really required for this for the computational physics course. Okay, if you have an idea, then it's obviously better. But I'm not teaching you. I'm teaching you that much of programming language which is required for this course, and not a little bit more. Okay, so this is the example of a list, and the indexing is the same. The indexing is again starts with 0. But you see, there are two differences here. One is that it is now mutable, and to differentiate it from the tuple, you now use square brackets for the collection instead of a parenthesis. The first bracket, you use third bracket if you wish. So I will. So let's call this AL, and this will be the example. And I have used the same numbers. It doesn't matter. So L is assigned, and again, exactly the same way I can call print different positions of L, the values in the different positions of L. Exactly the same way. Now the third one is a tuple, by the way. So you can have a list also inside. So let me ask you, if I want to print this 5, or let me call this 7. So if I want to print this 7, the value in this location, so what should I write here? AL
2, 1. 2 and sorry, not comma, 2 close and 1 close. Yeah.
So what you said also works. If I write it this way, this will also. Oh, okay, so this will not work. Sorry, must be integers as slices. Not all right, all right. So this doesn't work. It will work later. Okay. So what is the
5 rather than 7?
So you did not run the
because I did not execute this. So this block I did not execute before running this. So it was set to 5 earlier. Are you happy now?
Yes, sir, yes.
Okay. See, what is the difference between tuple and list?
So one can be changed.
So I can assign. We can assign a new value to a member. So let's try to assign a 2. Let's try to assign it a different list. Oh, it can be done. So you see, interesting thing has happened. Here, there were 3 numbers stored in this. But now I am storing 2 numbers. There is no problem in that. I can do that. That's because it's a list. That's because it's the 2 things. One is because it's a list, it's mutable. And it's also heterogeneous, means that it does not really care what type of things you are storing at different places. So previously a list with 3 elements was stored here. Now I can store a list with 2 elements or a tuple. It doesn't cry. I can do that.
So this tuple will not be changeable, right? Like although list can be changed, but this 1, 2 cannot be changed, right?
One second. So let's try to change this again to 4, 5, 6. See, I can do that because what I am changing is the 2 indexed object of the list. Okay,
So
that
try
I am
this.
changing.
So
But
try
if I
this.
one second.
Yes,
But
sir.
one second. But now if I want to change this, if I try to change this, what is it addressing? It is addressing this member in a tuple, which is the second or third member in this list. That I should not be allowed to change. What? Oh, okay. So I did not change it. So I got surprised. So say, so I am not allowed to change that because now I am trying to change the value inside a tuple.
Yes, sir. Yes, sir.
Okay. Any question? So we have learned 2 container types. When we will use these, so let's ask this thing. First of all, when I use heterogeneous data types, means as I said, and as an example, that you have different informations of a student, like roll numbers, name, mid-sem, end-sem marks, etc. Then it is better to use a heterogeneous data type thing because then you need all those things, all those different things as saved in the same tuple. But then when should I use a mutable and when should I use a non-mutable one? When should I use tuple? When should I use a list? Well, again, so when you need to change, so use a tuple when you don't want to change a number. Okay, like your mid-sem, end-sem marks. So even by mistake, I write a wrong line in my program, it will not change that. It will give an error instead of changing it. Okay, so then I will use a tuple. But if I want to change, then I will use a list. All right. So let me get rid of this also. This cannot be done. Okay. Let's come to arrays. Now, as I said, that everything that you, yeah.
So what you did in 77 and 78, like how to come 1, 2, and 4, 5, 6.
Can you repeat again?
So in 77 and 78, how came 1, 2, and 4, 5, 6 in close bracket?
How?
How came 1, 2, and 4, 5, 6? Sir, as you write 1, 2, and 4,
Okay,
5,
okay.
6.
See, these, what I am doing is, what is AL2? AL2 is whatever in this position, right? This index position.
Yes, sir.
Right? So this is 0th index, first index, second index. Whatever here is AL2, right? Now, in this line 77, what I am doing is, as I said, that it's mutable. So I'm assigning a new tuple instead of this list. I'm assigning a new tuple to this location. Okay. So after I doing this, if I print AL, then I will see that 373 is replaced by 1, 2.
Okay, sir. Got it.
Okay. So again, if I print here, it will be replaced by 4, 5, 6. Fine. So I can do that replacement. That's the point.
Okay, sir.
Hello, sir.
Yeah.
Sir, here in this example, we have replaced the list with the tuple. So
Right.
can we do same thing with this tuple at, like this is the 5 4, so can we replace this tuple with the list?
So this you want to replace with a list, right?
Yes.
So can you?
Yes. Okay.
Okay. Okay. So let's come to arrays, which is probably the most important ones for us. And so all these things, by the way, okay, so let's come to arrays. So we'll learn slowly. So it's ordered. As I said, everything is ordered. Now it is homogeneous. Every elements in a given array should be of the same data type. There is no escape from that. And it's also mutable, so you can change. Now, why do I need something like this? Well, the reason we have seen, what is the reason that we need things which are heterogeneous. But then, if I have something as heterogeneous, the problem is how this list, say for example, is represented in the memory location in the computer. The way it is represented, see, what is the difference between, so somebody tell me, the difference between a book and a list. So you have a list of papers and a list of papers, say, and you have a book. Both are made of papers, both has something printed on it. What is the difference?
Sir, in list we can change the order of the papers.
In ascending order.
Ascending order. So Raman says that order. Sushant?
Sir,
Okay.
books content is constant, but list of papers content is different maybe.
No, I say the same thing is written. So let me give you a concrete example. I give you a book which is in PDF format, and you take printouts of it. So you have n number of papers. Each paper is separate, obviously, and then you make a list of these papers, and then you buy the book from a store which is like nice binded. So what is the difference? So the content is exactly same now, right? Tanu?
Sir, if the content is same, then what can be the difference? I mean, it would be same.
So operationally, what is the difference between these two when you try to read one another?
Hello, sir.
Yeah.
Hello. Sir, we can shuffle
Yeah.
the paper in the list, but for the binding book, we can't do that.
Right. So that's very important that you can shuffle the papers in the list, but for the binding book, it is not possible, right? So for list to work, so imagine that so you don't have page numbers in these. Okay, somehow when you printed, the page numbers are missing. So for the book, it doesn't matter. Okay, so to find the nth page, so you have to search for it. It will be a little difficult, but it doesn't matter. The nth page is always at the nth position. But for the list, if there is a little bit of wind, it all goes around, so you don't know which page comes after what. So what you have to do is that for the first page, you have to write something at the end of the page which links to the next page. And so the end of the first page, say I write P, and the next page at the top, I write P again. So then when I have this all jumbled up, I can figure out that which page comes after what. Okay, so that's a list. And the computer list is almost works in the same way. The problem here is that the advantage here is that I can take out one element from the list or add an element in the list at my wish. Okay. Like, for example, when you are making a calendar for your this semester, maybe you joined the course a little bit later, and then you have 3 days of classes for that particular course. So you can just add that course. So Monday it is starting at 9 a.m. So you can just add that to your existing calendar. Okay. But what happens is, because you have to keep all these connections all the time, the list, it becomes, for the computer, it becomes difficult to track of a list, or it requires more memory to track a list or keep a list. Advantage is that you don't need to have a fixed length. It can be of any length, and then you can take out one to reduce the length or add one to increase the length, etc. So there is advantage, but it will become slower if I use a list for long calculations. For long calculations, what I rather need is a set of memory locations specified for throughout my entire calculation. So if it starts with 5 or 50 memory locations, at the end of the calculation, it's exactly 50 memory locations. And each of these memory locations, say all of them are either say integer, or all of them are strings, or all of them are floating points. I don't have one floating point, one string, etc. Okay. So that is the difference between a list and an array. For numerical computation, the example that we gave, like for the x positions of n particles, we'll always use arrays. Okay. Because the n particles, if n remains constant, we will always use arrays. So I can convert a list to an array, but so let's say array. So I can give n. Now I am defining this as NP arrays, and this way you can actually convert a list to an array, but remember that it has to be homogeneous. So indexing is exactly same, and it's mutable, so you can assign a array. So AA, my array. So these arrays can be thought of as vectors. I mean, to represent a vector, I can use an array, because the 3 elements in the vector, they have exactly same dimensions, etc. So I can use an array. I can have even more array in more than one dimension. I can have an array. Okay, so let's first see that what we cannot do. So that is important. So can I have, like we had earlier, can I have this 10? What do you think? Can I have this?
No,
Why?
because it is heterogeneous.
Because it's homogeneous. It's not heterogeneous. Yeah, because BB is heterogeneous, and your list is array is homogeneous. So I can. So I asked you what is the size of this the list. So I can find the length of a list. So AL is 1, 2, 3, 4, 5, 6. I can find the length of an array as well. That may be useful, right? Because so you read all the roll numbers, for example, and you want to know how many students are there. So just do length of in the roll number, so that gives you all the name of how many students are there in the class. Can I add AA with BB? So let's try that. Why it cannot add?
So
Because you
because
see,
one is
Length is different.
the length is different. So because, as I said, you can think of them as vectors and their length is different. So I cannot add. But if I had 14 here, so I have both the length as 4, then I can add. So what it does is it adds element wise. Okay. You can calculate the dot product if I think of these as two vectors. So how do you calculate the dot product? First element multiplied by first element, or 0th element multiplied by 0th element, plus first with first, second with second, third with third. So what is this doing? Again, it is element wise. So this is multiplying by that, this is multiplying by that, this is multiplying by that, this is multiplying. Okay, so I will request you to explore all the things that you can do by defining this type of arrays.
So can we do these things to the list also, that addition and all?
Why don't you try? Why don't you try? So we said how to convert a list to an array, right? See, this is a list. I converted that to an array. Just saying np.array. Let's do the opposite. Let's say that al now equals, I want this to be a list. So how do I do that? So I want to convert the array to a list. So it's simple. So I say toList. Now al is a list. So bl equals this is what you wanted. See, now what it has done is it has added the toList in the sense that it has added the numbers in the B after the numbers in the A. Okay. So this is, if I give you just like the example of papers that I gave you earlier, if I give you two sets of papers and say that put them in the same list, what will you do? You'll just add one set of papers after the other and then re-clip it, right? So that's what it has done. Sometimes I may want to add a new element at the end of the list, and that's called appending. So if I say I want to add the element 15 at the end of the list, so I do this al.append 15, and then you see that al was 10, 21, 33, 14, and now it has added 15 to that. I also said that for the list, I can insert something in between, which I cannot do for an array. The array is of fixed length, right? So how do I insert something in between, which may be required at some point? Let's try to do that. So al.insert. But I forgot how to do that. So I give a question mark, and so let's see what the help tells me. So it tells me that al.insert index an object. So if I want to insert, that means that if I want to insert an object at the, say, second element, second place, then I have to do al dot insert. Second place, I want to insert, what do you want to insert? Say 4. Okay. So now if I print al, see what has happened. 10, 21, second place, the index is here, so there it's 4, and it has pushed the other things in the right hand side. See, sometimes I want to get all the elements in the list which is above index from 4 and above. So 0, 1, 2, 3, 4 and above, 14 and 15. So if I do this, then what it does is it's called slicing. It slices the list here and returns me everything with the index 4 and above. And this I can also do with the array. Remember that array AA was somewhere here. So 2 and above is 33 and 14. So that's what it has returned. So this becomes very useful when you want to take a part of the array. Somebody was asking that what if I want to know what is the place in the list or an array, say in an array, just give an example, where the value is 33. So I want to know the index of 33. So let me ask one of you that Ninglum, are you there? Yeah, I come to your question. Shreyansh, are you there?
Yes, sir.
So if I ask you what is the index of 33? What is the index of 33?
2.
2, right? So, but how do I know that using a function? Because obviously here I can see, but if it's an array of size 10,000, I will not be able to see, right? So what I can do is, there is a function in NumPy called np.where, and I can do many things with this. So here I am doing a equals to 33. So if you look at carefully, I have used 2 equals to signs. This is because what I want here is not to assign the value 33 to a, which I was doing when I was doing a equals to 33. I want to ask the question, where is a equals to 33? Okay. So this, if I do, then it tells you, it gives you an array which has the index where 33 appears. Because so this is particularly useful. Like for example, I want wherever 33 appears, I want to change it to say 3. Okay. What I can do is I can do np.where. There can be a little bit of glitch here because different compilers works a little, different Python works a little bit differently. But let's see. So I say np.where a is 33. So this gives me the index. This gives me the array positions where a is 33. In this case, it is 2. And I want to assign it to say 3. Okay. So what it is supposed to do is wherever a is equals to 33, it will change to 3. It's so obedient. It has done that. You can also, instead of doing this, I can say where AA is greater than 10 or greater than 11, assign it to 0. Okay. So this was changed to 3, and now everything other than 10 and 3 is assigned to 0. Any questions so far?
So here at the line 104, we have got just the two elements after the fourth index. So can
Right.
we do the opposite of it also, like before
Right.
that particular index?
Very good. So if I want AL 4, then let's see what it gives. Okay. So up to the fourth element, or okay. So up to, see, when I so this thing which you have written here, now it is returning everything before that element. So 4 is here, right? 14. It returns everything before that element. You can even do this. So you'll get 2 and 3. The second element and the third element. Fine. I can define two-dimensional arrays as well. And so sometimes you may, so there are interesting functions in Python, in NumPy, and I will request all of you to go through NumPy in the sense that you can search for NumPy examples in internet and see that what are there. Okay. Just explore. So one is, so let me use one such thing here. So what is np.zeros? So np.zeros creates an array with all elements as 0. Okay. And then I have to tell you what is the shape of the array, and which I do using a tuple. And this tuple, so I want a 4 by 4 array. So this is like a matrix. Sorry. 4 by 2 array. So what is this? This is like a matrix. There is a reason I did not do 4 by 4, but so A2D is like this. I could have done 4 by 4 also. It will take only a little bit extra place. But you see that how have I written? So how is this written? So this is a collection of 4 one-dimensional arrays, right? Just try to do the opposite and see. If I do this, so it will be now two-dimensional arrays. Sorry, 3 two-dimensional arrays. Sorry, 2 three-dimensional arrays. So this many number of arrays, and this is the dimension of each array. And these, so if you look at carefully, this is a list. This comes within that list type of bracket. This is another list, and they are of the same size, so they are homogeneous in between themselves. And these two list is collected in another list, and again they are of the same size. Both of them has the 3 elements each, and then that is the entire thing is then an array. So that's how it is done. So now this is a two-dimensional array. So I can define matrices. I can define even 3-dimensional arrays, which will be difficult to see, so I will not do, but you can say 2, 3, 4. So it will be a 3-dimensional array. So you can define n-dimensional arrays in Python. So these are called ND arrays. But given an array, so say A2D, how do I know that what is the dimension of these arrays? What I go do is, so there is a shape function. Yes, I don't need. If I do A2D dot shape, this tells me, this essentially returns to me this tuple. So it tells me that what is the dimension of this array. And many times this will be useful for you to know the dimensions of this array. Okay. Any questions so far? Any question here?
Sir, same command is also used for ones.
Same command is also used for
Ones, like 0, 0, so 1, 1.
Right. So very good. So I can also have so where is A2D and there is, I didn't define B2D. So let's call this B2D. So I can also define this as ones. There are many other things. That's why I am saying that please explore. So we have seen some operations with arrays and lists. So let me just show you one operation with a string, and that will give you very good. That will be good enough. So if I do this, so what I'm doing here is I'm adding 4 strings. So let's see what happens. So it just adds the characters of the string one after other. So these are called characters. So this is one character, another character. It really doesn't know what you have written. It just adds all the characters. If I give gaps here, so then this will become a sentence. I mean, this is also a string, but with gaps now. If you want, at the beginning, you want a tab. You know that there are these tabs which you can use. You have a tab in your keyboard also. So this puts a tab at the beginning. So, here it is, okay. If I do a print, then it will use a tab. It doesn't start from there, it starts from a little later. If you want, after this, if you want, it will be in a new line. So that new line is done by /n. We will see the next one start in the new line, and there is no tab, so it starts from the beginning. Okay. This is just, many times we will write comments as the code executes, like we had written long ago. We wrote one program here. So here sometimes you may need to do these things. If I have 2 different print statements, so this print statement came after this, you'll see that that new print statement started with a new line automatically. You don't need to say /n here. If I do /n here, then what will happen is it will have 2 new line characters. So it automatically got a new line, and then again there is a /n, so I have another new line here. So we used, so let me go back to it again. So you used a conditional here, like if AA is equals 33, that's we checked. If that condition is right, then we said that what is the index in the array where it is 33, right, or greater than 11, etc. So the conditional that we learn is called if, and this is the syntax. Syntax means that how the way you have to write the code, in the general way you have to write the code. So if inside the if you give an expression, so this is the condition. So let me write condition. So if this condition is true, if the condition is true, following is executed. Whatever is there after this, if that will be executed only if the condition is true. But how much of the code will be executed? Because there is, you see that this if may come in the first line of your code, and then there are 1000 more lines in your code. The way you tell that, if you have done C, you know that you write the curly bracket or the second bracket. Here you write a colon, and the next piece of code which is the executing thing under this if has to be one tab apart from where I starts. So I have written this like this. In Google Colab, once I hit enter here, it will automatically come one tab apart, because it knows that you are now trying to write something which will be executed under if. Let's say that we are writing a little more complex program where if this condition, so this condition 1 is true, then the following is executed, and then there is another condition, condition 2. If this is true, then something else will be executed. Okay, so now that will come here. Now this is very, you have to meticulously be right that all the lines under this if uses only one tab character. Otherwise there will be error in your program. Similarly, this else if starts with the if because they are the same type of conditional checking going on. So else if means if this is not true, then it will come here, and again you are checking another condition. And eventually you will say that, okay, so if nothing is true, then if nothing is true, so there is no condition now, then you say print, execute something. That is the syntax of the if command. That is the syntax of if. So we'll look at an example. And remember that every time, so once all these things are finished, so then you write the rest of the code going back to one tab, going one tab back. So let's see an example. So it's very trivial example. Say, just define two variables with two numbers. So if AA is 1, print AA. So I'll just print the name AA. If AA equals 2, okay. Okay. See what has happened. A is set as 2. So it first checked if A equals to 1. We have seen that this is to check if the left hand side and the right hand side are same. So that is not true. So it has not executed this. So it has come here and checked if A equals to 2, which is right. So now it will execute this, not 1. And once it is executed, then it will come out. So it will not go to the rest of the code. So it's not, only not 1 is executed. So if I set A is 1, then A will be executed. If I set A equals 5, then still this is executed because A is set as 5 here. But when I run the code, it is reset to 1. Okay. So this is how a condition will work. Now, we have seen one conditional operation, which is whether you are checking both of them are same. But what are the other examples? So I'm just copy pasting from somewhere in internet here because I don't want to write them down. So that to check equals, you do this. If you want to check if they're not equal, so you put a exclamatory sign which is not, equals like this, less than or equals to is this, greater than equals to this, and then there can be other things which let's not bother about right now. Okay, so any question here?
Sir.
Yeah.
Sir, in the condition, we also can operate like AA and plus BB.
Yeah, you can do that.
Okay, sir.
Sorry. This is what you want, right? What will be executed now? What do you expect?
Sir, last one.
Not one. Let's see if it works. Yeah, why not one? Not one will not be executed because A is not 2, right?
Yes, sir.
A is 1. The first thing is checking if 2 equals to 1 because 1 plus 1 is 2. That is not true. The second thing is checking if A is equals to 2, A is 1. So that is also not true. So it will come here. Fine.
Sir, we can also give in print AA plus XX.
Here.
Sir, in the print.
In the print, yeah, in the print, whatever you want. So this is just an example. I mean, obviously, you will not just print, you will do a lot of computations here, right?
Okay, sir.
Okay, so we'll do one program and we'll see that how this all works out. Because I want to just go through the last concept today. All these things you can now use in the, there are few problems. So I will request you also try those problems. Okay, if you cannot do that is all right, but try. You will only learn if you try. Okay, I'll show you where the problems are. So the last thing that we'll go through, so these are the minimal things that one requires, is a loop. As I was saying that a computer is, last time we were saying in the class that computer is very good to do the same operation many times. And loop is what does that. So it does same operation many times. And we'll learn a particular loop today, and then there are other loops, other type of loops, which can be, which you can in the internet. So it's called for loop. Okay. So what is the syntax? Syntax is again how do you write the loop in the language. So I say that for, let's do it in an example, and you will learn that there can be many other ways it can be done in Python. So let's say that we want to so you want to print all numbers between 1 and 10 or 0 and 10. So you have something which, see, you are doing the same operation many times, in this case 11 times, right? So let's say 0 and 9, so 10 times. You are doing the same operation 10 times. Okay. If I am doing the operation the nth time, so that n is this ii. So ii is basically ith time I am doing the operation, and again I am using 2 letters or 2 characters to use the to define the variable. And then I write ii in range 10. So what it does is that it is going through all the values between 0 and 1, 0 and 9. Okay, 1 less than 10. It will go through all the values between 0, which is where it starts with, and 1 less than 10. Sorry. And then I say print ii. Okay. Let's say this is how the syntax works. I just wrote it with an example. The thing is that you give what the loop is for. So what is how many numbers that it will go through here? What are the numbers it will go through here? And then you write a statement. So now this statement will again not be one statement, but it will be many statements or many operations that we will do here. In this case, we are just printing I. Okay. So let's just run it and see what happens. See, it has printed from 0 to 9 as expected. One thing, just like for this ends with colon, after that you have exact 1 tab character here. Okay, so that is the syntax, and so long you are maintaining that tab, so all the things that is under that tab. So if I print here etc., so then everything which is under that tab, so that will be within the loop. And then if I go out of the tab, why I am writing? If I go out of the tab and print something, so then that will not be printed within the loop. So that will be printed only once. So let's see. So you see 0 times 2 is 0, 1, 2, 2, 4, 3, 6, etc., etc. This is outside the tab, so this is printed only once. Okay, any question we'll take, and then we'll quickly look at one program. You're not audible. Okay, so let us try this one example, and it's a long day already, so we'll not bother you. So find all the numbers. So within, say, 0 and 99, those are divisible by a number that you give in input. Okay, this is a problem that I have to do. So this is now kind of coming to a real problem. So first, I start by writing the algorithm, which is just take the input number. Now what I can do is I'll collect all these numbers, right? So I'll start or define an empty list. This list will contain eventually all the numbers which are divisible by a number that you have given in the input. Now what can be the algorithm? Let's see whether it is divisible or not. It's very simple. I will do remember there was a way of finding the remainder, so I will just see that if the remainder is 0. If the remainder is 0, then it is divisible, right? But that I have to do for all the numbers between 0 and 99. So I run a loop. Within the loop, what do I do? So within the loop, I check if. So now I have to use a if statement. II store it in a variable. So this number is say AA. So II divided by AA is 0. If yes, add it to the list. So say the list is B. Out of the loop, print the list. So this is always. So when you are writing a code, it is that you have to write a pseudo code and then you have to implement it. These things we have already. Let's do an integer now. Now I will start the loop, but before that I will define an empty list. So how do I define an empty list? Very simple. DD is a list, but you don't put anything within the list. So that's an empty list. Okay. So now II will be in the range. So it's 0 to 99. So if I say 100, so it will run up to 99. Now I need a condition, which is this. The II percentage, this is 0. You are checking whether the remainder is 0. What do? I just append II to the list. So, for example, if I have given A equals to 2, so then when it comes to 2, this will be true because 2 divided by 2, the remainder is 0. So 2 will be added to the list. So I come out of the if. You see that there are two tabs here. One is happened because it's inside for. The other has happened because it's inside if. So I just come out of everything and then I print. So that's it. So tell me a number.
4.
Okay, so that gives you everything which is divisible by 4. So I will not do anything further. There are different types of problems, different problem sets here. So CA, CD, and CH. You should start with D and then go to A and then go to H. So try as many as you can. I will not tell you what to try or not. So this just try as many as you can. You may need a little bit extra than what we have gone through today, but that is all right. Whatever you can do, you can do. And any question we'll take now.
So you have to start from which one?
D is supposed to be the problems in the discussion. A is class assignment and H is homework. So D, A, and H.
Okay, sir.
Okay, so D is the easiest ones. Then the more complicated is A, more complicated is H. I have tried to record today's full session. If it has worked out, then I will upload it. Means that I don't know which screen is being recorded.
Can you share the program?
Can you share the
Program.
So this thing is already shared with you, right? This is something which will always be available. So it's there. Okay, this entire thing, I will work on this again in the next day. So this is there. Okay.
Okay, sir. Yes.
So, sir, in the file which we will share to our tutor, we have to solve the questions.
See, right now you don't need to share anything. So it's a homework, but you don't need to show it. Okay. So next day also. So next day we'll start at 3 instead of 2:30.
Yes, sir.
Okay, we'll start at 3. We'll need a few more things to learn in Python. So that we'll do in the next day. After that, the tutors will do the job. Okay. So then next day, at the end of next day, we'll fix all those things.
Okay, sir.
So next day we'll start at 3. There is one more thing. Tomorrow's class we'll have at 11. So as we figured out that there is no class at 11 for any of you. So we'll have the class at 11. I will also send a posting WhatsApp. So Friday class will be from 11.